There we go.
I'm trying. Oh, hello. It's loud. We're on week 8, right?
Okay. Here,
yes,
give me a second.
week 8.
Oops.
I'm pretty sure. Yeah, week 8.
Okay. Not gonna lie, I hate triangles.
There's something different.
Okay, sorry about that.
I don't feel like it would be that bad if I could just remember all the stupid formulas for everything. But I mean, it's been so long since I've done anything with triangles that it all escapes me.
Yeah.
That's fine. Whatever, though. I'll be right back. Hang on 1 second.
Okay. You like sitting down in Walmart?
That's cracking me up. That's really funny. Okay. Oh, I guess we'll start when Addison gets back.
Okay. But yeah, I'm like the same way. I get the first half of things, and I get like the SOHCAHTOA with the triangle, figuring out what's over what. Then I just get confused how they're like, well, do the sine part, plug it into the cosine part, and then get tangent part. Like, why is there so many steps to it?
Trying on purpose. Like they make things more complicated than they have to be. But I guess it's good because it requires you to think and whatnot.
Yeah. In the meantime, here's a cat.
Yay! I miss my cats.
Aw. Are you here for school?
Yeah. I'm from Washington.
Oh, okay. I had a companion from Washington State.
Yeah.
Okay. He was from Seattle, I think. Probably should remember.
He's been gone a long time.
What was he doing? I don't even.
Yeah,
I don't have too long tonight, so
Yeah,
I was
same.
hoping we'd start more 7:15 because I've only really got till like 8. So
Yeah.
Maybe.
I mean, we'll do what we can before 8. I think at least just because.
Yeah. And what is it today? We're just doing the extension problems, basically.
Yeah, so it's not even. It's just review the prep and extension problems. I don't even think it's that bad.
Yeah. The first hangout of the week isn't really that bad.
Yeah, I actually like this week. I haven't looked at Thursdays yet, but I like Tuesday.
Yeah. Okay, should we get started with a prayer? I guess I can go ahead and say that.
Okay.
Our dear Heavenly Father, we thank Thee for this opportunity that we have to gather together in each of our locations to study math and to better understand the triangle. And we ask Thee to bless us that we may be able to remember what we have studied and understand what we are studying together. And we say these things in the name of Jesus Christ. Amen.
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 Okie dokie.
Oh, perfect.
Discuss and make sure each team member filled out the table properly from the preparation activities. Oops.
And the table was the range of all the inverses.
Okay.
Yeah, did anyone have any questions about that one? I know it talked a lot about the inverses. What's it mean?
Oh, those are right. Here.
Though, huh?
Go ahead.
Oh, no, I was going to say, I mean, if just to make sure I understand it, in part 1 of the prep activity, it had asked if any of them are 1-to-1. None of them are 1-to-1, right? Because that would be wouldn't that be the horizontal line test? And all of them have some form of multiple values there.
The inverse ones?
Yeah, sorry. Or no, I think it said that, like, yeah, are any of the 6 trig functions 1-to-1? But I got none of them were.
Oh, because I have that they. I have that they all are 1-to-1.
Well, because the 1-to-1 is if there's one x value to one y value, but since, like, you know, not counting in the range, just counting like the sine function as it repeats its period over and over, it's going to pass the or it's going to fail the horizontal line test because you're going to have 2 values of y per 1 value of x.
Isn't it vertical line test?
No, I think
that's for a function. The horizontal line test is the 1-to-1 test.
Yeah.
But does that even apply on this?
Oh, the horizontal. Because so here I've got the inverse functions like right here, just graphed out kind of roughly, but so what you're saying is that the vertical line test?
No. The inverse are 1-to-1, I believe. What I was asking is if the basic trig functions, those are not 1-to-1, right?
I know sine and cosine aren't. I think tangent is.
Yeah, because isn't a tangent the weird side squiggles?
Yeah, it's like kind of. But everything else, and then cotangent is like the same as tangent, only flip-flopped. So.
Where are you guys at?
I was just asking about the prep question. I had a question about it.
Did you guys just barely get started?
Yeah, like 5-10 minutes ago. Not that long. Yeah, I think the cosine, sine, secant, and secant are, or secant and cosecant. But cotangent and tangent are, yeah, because they pass the vertical line test or the horizontal line test. Does that make sense?
Yeah, I didn't think cotangent did either, though.
Cotangent looks like, that's tangent. So cotangent looks like this.
Yeah, but doesn't it repeat over each period? So you get that repeating again and again.
Oh.
Which,
I mean, what it does. Does it just like, does it get closer to the axes or does it wiggle around?
No, it repeats itself. So like that squiggle is one period, but you're going to get repetitive squiggles. If that makes, I don't know if that makes any sense. Like you're going to get repetitive squiggles things.
Okay.
So I mean, if we're talking about it in one chunk of its period and the cycle, that it will pass the test, but just like sine and cosine,
continuing on, it won't. That makes sense to me now.
That's what I was trying to verify. I wasn't sure if I was looking at the right things or not.
I guess it wouldn't then. Huh. Okay.
Yeah, but I think that's one reason why with the inverses we had to find the ranges to see them all in a, I guess, a more controlled part, because elsewise this doesn't really apply if we're just repeating it forever.
Got it. That makes sense. Does anybody, does that answer your question? I don't know.
Yeah, I think so.
Okay. Does anybody else have any other questions about the preparation activities?
No, I don't think so.
Can you drop it out there? Like 2. Um,
You want to move on to the extension?
yeah, we can do that.
Not really, but I guess we kind of have to anyway.
Right.
Oh,
All this
So-
tan and sine and cotangent and all this crap just confuses the heck out of me. I just kind of flow with it. Use my calculator through the whole thing.
Right. Well, geez, I was doing
Right.
the assignments, and I felt like it's like, oh, what's the inverse sine of cosine something, and I'm like, how about square roots of 3/2? And it's like, fantastic. Sure, I'll just type in things and it's okay.
yeah. Okay, it says.
I can do tangent of 5 pi over 6.
Okay.
I guess I'll do sine negative 5 pi over 6. I guess there's two of those. Huh?
Yeah, that one's on there twice.
That's a typo. If you look in the answer key that it gives, there's a different question for that second sign.
Oh, is there?
Yeah, so I think just this part is a typo.
Well, I'll still do the negative 5 pi over sine, or 6, whatever it is.
I could do cotangent of 9 pi.
Yes, I was right.
Whenever I clear the memory on my calculator, it goes back to degrees instead of radians.
That always confuses me.
I'm like, wait, what?
So if you have one of the TI 84 or 89, you can actually take it online, hook it up to your computer, and download a bunch of the fun games for it. Side note. They're entertaining.
That's all I used to do in high school. I just look for the ones that had the games on it, and that's all I would do. That's probably why I don't know how to do this crap.
So
I think I got my answer, though. Check and make sure it's right. C. Which one was I doing? Yeah, I got it right. That's surprising. Done something right for once.
Right, that's tough, yeah.
Everyone ready?
Yeah, I think so.
Yeah, I'm good.
Ben might not be.
I have a question because I'm not getting the right answer for the tangent one. I did a couple of the others and I got the right answer, but is there a typo in the answer key?
Which one is it?
Tangent 5 pi over 6. I'm getting negative square root of 3 over 3. The answer is negative 1 over square root of 3.
What's the answer you're getting?
Negative square root of 3 over 3.
Negative 1 over square root of 3 is the same thing as square root of 3 over, or as negative square root of 3 over 3.
Oh, is it?
Yeah.
Okay.
Just times. So you take your answer, the 1 over, or
Square root
the
of
other
3 over.
Yeah. What's the answer it gives? 1 over square root of 3?
Yeah.
Right?
Negative, but yeah.
Yeah. So you just times both the top and the bottom by square root of 3. And you get what you got.
Well, wouldn't that be... Oh, okay. I see what you're saying.
Yeah, that's essentially just timesing it by 1. But
Yeah.
you're just moving the radical out of the denominator.
Okay. So my calculator just solved it more for me. Okay. Well, I did the cosine and then the tangent with the negative 1 too. I don't know if anybody else did that one.
Did I do? That was the second one?
Yeah, I did the second one too. Did somebody else do that or?
Oh no, I didn't.
Okay. Well, I just plugged that in my calculator and then I got square root of 3 over 2. That's what the answer was. So.
That's what I got.
Wait, the answer key says square root of 3 over 2.
Yeah.
Yeah, that's what I said.
Oh, okay.
That's what I meant to say if I said something different. I've been a little spacey.
Oh, sorry. My computer cuts out. I probably hear half of what I should.
Yeah, my internet's been kind of weird today too. I have it plugged in and everything, and it's still not working the way it should.
Right. For the inverse sign, I got pi. I originally got pi over 6, which is the answer, but the answer is negative pi over 6. And I just wanted to double check. Since it's inverse, is that what makes it negative?
So if you look,
or am I just having faulty logic here?
Well, if you look at your circle graph thingy-majig over here, for sine, if you're looking, so you look for the sine, or where the sine is equal to negative 1 over 2, and that's this, I don't know how clear that is, but that's this angle right here, which is 0, and then you have to go all the way around to get to this, or you could say negative that angle, which is just pi over 6. Does that make any sense?
Yeah. In fact, I was about to say you're pointing to the wrong point, but I forget it's flipped.
Like, yeah, flipped or whatever weird.
Yeah. See, I was just wondering, is that all it is to find it? I know a lot of these keep saying try not to use any resources or stuff. Is it okay to look at the unit circle for the resource, or do we have to memorize it?
I'm hoping
Or
we
does
don't have
it?
to memorize it, but I'm thinking that's what's reality or something.
It
Yeah.
said try not to, so I'm not. I can't memorize that whole circle.
Yeah, I didn't use my calculator for this, but I did use the unit circle. I don't know. I wouldn't be able to use any, like, not use any resources at all.
Yeah. Okay.
So what I got for the cotangent of 9 pi is this angle right here. And so the tangent would just be sine over cosine, or 0 over -1, which just would be 0. But since it's cotangent, it's flipped and the zero's on the bottom, and you can't divide by 0. And so the answer for that that thingamabob is just undefined.
Okay. Makes sense.
All right.
Is that all the ones that everyone did?
Yeah.
So,
Does anybody have any questions about them? No, go ahead.
I was just going to ask the formulas for, I forgot how to say the CSC. How do you say that?
Secant?
Yeah. Like, was that sine over cosine or cosine over sine?
CSC, that's cosecant, right?
Yeah.
That is. Go ahead.
I wasn't saying anything.
Oh, okay. So this cosecant is the opposite of sine. So instead of opposite over hypotenuse, it's hypotenuse over opposite.
Okay. So is it 1 divided by sine?
Handy dandy resource. Yes, exactly.
Okay.
That's the paper I need right there.
Same, and then this.
Was that in the resources?
No, this was at the math lab on campus. If you want, I can take a picture and scan it to you guys.
That would be very helpful.
Yeah, that'd be awesome, man.
Okay.
I'm telling you, like, half the links in this don't work.
Yeah.
I was like, I looked at all the stuff for resources and stuff this time, and I'm like,
yeah.
Okay. Then the secant, is that 1 over cosine then?
Yes.
Okay. Okay, well, I can do the cosecant.
I'll do that later. Okay.
Well, the first one asks that be sure everyone in the group does at least one and explains it. So since we all did one, I don't know if you want to move on. I only have like another 20 minutes max on here, and I'm recording, so I can just like leave the laptop alone if I have to leave early. And I don't know.
Just end up recording like 3 hours because you forget about it.
Right.
Come back later. It's just all of us have left already.
Okay, yeah, we can move on to number 2.
Yeah, I think my big thing is I have to go to work at like 8 o'clock in the morning, so I have to get up at 7, and it's already 9 for me.
Oh, yeah.
And so I'm like kind of fading.
Okay, we'll try and wrap this up.
Sounds good. I think we've only
Okay.
got a little bit more.
Oh wait, do we need to do that triangle stuff?
Yeah.
Yeah, there's like 50,000 triangles.
Yeah, the rest of the extension problems are just triangle problems.
Heat triangles. Okay, given the following triangle, solve for the unknown pieces. Discuss the method used to solve and why.
So, I guess to start, we can take, so we know 2 of the sides for that first triangle. So what we can do is we can, yeah, and one of the angles. And so to find that other side, you just use the Pythagorean theorem, where you take the 2 legs, or so yeah, square them, and then that equals the squared, or the hypotenuse squared, or whatever. And so you just work that out, and you get b is equal to 3 times the square root of 21. And out that angle, the alpha, I think that's what it's called. Take sine A is equal to the opposite over the hypotenuse, which is 6/15. And then to get rid of, here, let me show what it'll be easier.
You sure?
So we have the sine of this degree is 6/15. And then to get, so you have this degree is what we want to solve for. So you need to get rid of the sine. So you take the inverse sine, which cancels those 2 out on that side, which is then the inverse sine of 6/15. And then you just plug that in your calculator and you get 23.6 is this angle.
And that gives you the angle for A.
Yes.
Wait, I didn't get that. What did you put in? You said sine 6/15?
The inverse of the sine. So sine to the -1 kind of thing. And then of 6/15.
Oh, okay.
Yeah, because the inverse gets rid of the sine on one side, and it takes the inverse of the 6/15, correct?
Yeah.
Okay.
And then I just took that angle, and we already know that this angle is 90 degrees. So we took, and then the sum of all of the degrees inside the triangle is 180. So I did 180 minus 90 minus this degree to find this degree, which is that.
Okay.
Does that make sense?
Real quick, on the top bit of work with the square root of 15 minus the square root of 6.
Mm-hmm.
Or sorry, 15 squared. Would that be? I didn't get 81. Oh no, 189.
It's 189. Yeah, sorry, it's kind of like weird in the camera.
Okay. Oh no, you're good. Yeah, that I don't know. I heard something funky. Okay. So in the other triangle, the angle A would be 61.5 degrees.
Yep.
Yep.
That's what I got.
Huh?
That's what I got.
Sweet. That one you just kind of work backwards like we worked the first one.
Yeah. Yeah, you do the sine to find the sine of one angle to find one of the sides, and then the sine of the other angle to find the other side. Or you could use whatever trigonomic thingy-mabob you wanted, but I just found sine was easier.
Okay, so on number 2,
Mm-hmm. Number 2, yeah. The triangles.
yeah, sorry, I sometimes think out loud.
I think I'm going to go ahead and call it a night, guys. I'm kind of fading away. But I'll see, well, whenever we plan on meeting next. I guess you guys can just text me.
Okay, yeah. Is everyone good with tomorrow?
Yeah, I'll be fine with tomorrow.
That should work.
Okay.
Tomorrow works best for me, yeah.
Sounds good.
Alrighty. See you guys.
See ya.
Night.
Night.
Kelly, it's already 8:05.
Yeah.
Time
I might have
flies
to
when
jump.
you're having fun.
Or
So
when
did
you're
it-
suffering through trig.
Yeah.
See. Yeah, if y'all want, I gotta go run. I gotta go run to the store before it gets too late. I can keep this running if y'all want to keep doing things. And I'll just shut it off.
We could put this on hold until tomorrow if you all wanted. We could like go over one or two of the last problems and then start on the next things.
Okay, that sounds good.
I'm fine with that.
Okay, yeah, let's do that then.
Okay, maybe we can work through number 3 because it kind of goes through a lot of the step-by-step bits, and then we'll
Yeah,
continue.
definitely.
Sounds good. I'll get this posted when I get back.
All right, sounds good. Have a good